Hi, I am IT PhD and today I'll tell you about binary subtraction. I'll explain everything very detailed and very careful, so even if you just met its first time this topic, you would understand everything. So maybe I think if you Google this, you know that there is a table for subtraction, and it doesn't make much sense. I mean, it's show you how it's done, but it doesn't explain you why it's so. So these three points, they are all right. Yeah, it's all right. You could understand it. But this one, it doesn't really make a lot of sense. And today I'll explain you why this table is such. So let's first start with very simple thing. So we would take a very small number. We would take just number 4 and we would subtract from it number 1. You could say, okay, it's too easy, but it's actually where we would start, and then we would come to more hard some examples. So you may know that each of the number in binary system, it has its own kind of a base of 2 power, and it has kind of, like, you could say that it's a weight. So we know that in this rank we have number 4, and here will be number 2, here 1. So the thing is that when we subtract something, we should borrow from upper rank if we have here 0. So if you have here 0, yeah, what you should do? You need to borrow it from other ranks. So for example, here we have also 0, so we need to borrow it from here. Yeah, so what we do? We take this rank, which is basically it's a 4. So 4, it is 2x2. Yeah, so what does it mean? It means that if we borrow this rank from here, we leave here 0, okay, but then here we have not like in decimal system, we have here not just regular 2, we have here twice 2. So if we want to borrow some more from here, we borrow this number. So we take this number 2 and we put it here. That's why here now we had kind of 0, but now we have 2. And 2 minus 1, it's 1. Then here we do not have this 2, but we have this 2 left. And this 2, it's actually 1, because this is base of 2, you see? This is base of 2, that's why we have here 1. So we leave it as it is. So the answer, it was 4 minus 1, it's 3, which is basically this number. Now let's move on to more complex examples. Let me turn off my sound. Yeah. So more complex example. Let's take number. Now let's take number, bigger number, just bigger number. We would make a lot of examples today, so everybody would understand. And let's subtract from it something more complex. So we would take number 8 and subtract from number 3 in binary. So again, better always to, when you're just learning stuff, to write here a base. So we would write the base for 8. Now, as we want to subtract from 0, we want to subtract 1 at first here. So there is a 0, so we need to borrow from upper ranks. But we have 0 to here too, and here we have 0 too. So what to do? We take it like, okay, 4, it's so this 8, we take this 8, and this 8, it's basically 4 twice. Yeah. So we took this stuff here, and now we have here kind of 0. Yeah, so we took it, and here we have twice 4. So we need to borrow one of these 4s, because it's base 4 here. You see, it's base 4. So we need to take one of these 4s. We have 2 of them here, 2. So one of them we are taking here. Yeah, so only 1 4 left here, and we take 1 4 here. And 4, it's basically, yeah, I think you know that it's 2 twice 2. Yeah, because it's kind of our second rank. And here we also borrow this 2. We borrow it here. So now we have here, we had here 0, yeah, but now we have here 2. So 1 minus 2, it's a 1. Here we have 2, but this 2, it's kinda, actually it's rank 2. That's why we have here 1. So one of this rank left. So 1 minus 1 will be 0. Here in this rank we have left only this 4 left here, and here it's 1 rank, because it's 4 rank and we have 1 left here. That's why we have here 1. So we have 8 minus 3, and we have 5 here, because this is a 4 and this is a 1. Yeah, I think it's quite understandable. So let's make some more. Let's take very big number with a lot of zeros, so it will be like more understandable for us. Yeah, it's big number, you see, and we would take from it some other number like this. So what we have here, we have 7-bit number. So each of these in computer science, each of these digits, it's called a bit. So we have here 7-bit number, and we subtract from it 5-bit number. Let's start. First of all, again, we need to simply write our base, our weight. As you remember, it's important for us not to make mistakes. So it's very easy. You just, as the base, it's power of 2, so you could just multiply the next number by 2, so it will be 64. Yeah, let's make it even 8-bit number. 8-bit, like in computer science, a lot of numbers like chars, they are 8-bit, so it would be more fun. It wouldn't make difference, but it's just fun to have it like this. I like 8-bit, it's my favorite size. What is your favorite size for binaries? So mine is 8-bit. So, and the max number, which could be written in 8-bit, just fun fact for you, it's 255. Because if we would like make addition of all these numbers together, it will be 255, and you may meet such number in computer science a lot. Okay, so let's start our work. First of all, we look. So we have here 0, so we need take from this rank, we need to take stuff here. So basically, this we have 2. Yeah. Let me use a color. We have 2, and if we would move this 2 here, it will be like just 2, and that's it. So it wants 2, we take 2 one time here, because it's base of 1. And the result will be 1, logically. As we took it from here, now here we have a 0. So this is a 0. So 0 minus 0, it's 0. Now here we have funny place where we subtract a lot of stuff from zero. So we need to borrow, and we will borrow from here. So we take this 1, and this 1 becomes 0. We take it here, and we know that, okay, so actually this 64, in this base it's like 32, 32 by twice, but it's better like look into it in a bit different way. So you could say that this is kinda 2 in 0 power, this is 2 and 1 power, this is 2 and second power, 2 and third power, 2 and fourth power. So you see the logic. So we have everything. Here it's just a power of 2, basically. So here we have this place, this one. It's 2 in 5th grade. So you may also already remember that, okay, it's 2 in 5th grade and it's 32, yeah? So now we have this 2 in 5th grade, so we need to move 1 grade down to 16. So we take this like half of this number, yeah? So we already moved here like 2 of them, so we take half of it, we leave it, 1 we leave here, and this half we would put here. And now this half, it's basically 32, and 32 it's 16 multiplied by 2, and 16 it's 2 in the fourth power. So again we need to take here, we kinda leave 1, this 16 we leave it here, but second we move to the next place. So 16, we moved 16. Now let's write it. So we put it here, and 16 here it will be 8 twice, yeah? So we put it here, this 16. Now we have to take this thing too, which leave us here, this one lives here, and 1 we move to another rank. So we move it here. Now we move this 8, which we have it, we moved it here, and 8 it's 4, let me use other color, 4x2. So now it's the place where we should stop, because here it's the operation where we currently work on. So we have here, this is base 4, yeah, weight 4, so that's why we kind of have here 2, yeah, it's two sticks, you could say. So one of these sticks we kind of remove it, you know, and because we subtract, yeah, and 1 leave, so we write here 1. Then here we have 1, here you see, it's because it's like leftover, and we have 1 here, and this is 0. Here we have also 1, and here we have a 1, so it's also 0. Here we have 1 because it's like leftover. Here we have 0, and here we have 1. So let's now calculate our number. It's easier to take it's much easier to take for us calculator now. So yeah, by the way, it's very good option for you when you learn to use calculator, because there is a Windows calculator has different modes and it has programmer mode. So in programmer mode you could simply choose what number to put, but let's for now, for tutorial purposes, we will just make some addition. So 128, I take this number, plus 64, it's this number, this one, plus here we have 2, it will be 194, and you could compare our number, this number, you would compare to this small number. You see, it's right. So let's write it down. 194. So we want to subtract from it this number. It will be much easier to count. So it's 1 plus 4, it's 5. 5 plus 8, it's 13. And 13 plus 16, it's 29. So we make subtraction 194 minus 29. And yes, let's again use power of technology. 194 minus 29. It will be 165. So basically, this binary number which we have here at the bottom, it's the same, you see? So we made right calculation. Yeah? This one, this number which we have here, it represents us 165. And it's kind of the same. So you could always kind of check, did you perform your calculation right? And to check, use a calculator. So it's 165. That's it for now. I think I gave you a general idea how it works. So now you could actually use this table. Oh, yeah, it's a good table, but it's actually just, if you do not understand how it works, this last part, this last bit, it's actually just making nonsense. So I tried to explain to you why it's so. Don't forget to subscribe to my channel. I'll make more videos about it, and mainly I make videos about programming, so in C language and in Python and other languages we will have. So hope to see you in my channel. Bye bye.